Hello, this is Mr. Stansbury. I'm going to take you through the notes on periodic behavior. At the end of this, you should be able to say, I can find the values of the principal axis, the minimum, the maximum, the amplitude, and the period of periodic functions, and I can graph them. Okay, it's a lot of stuff, but we're going to be okay. All right, first thing, what does periodic even mean? Periodic is something that repeats itself horizontally over and over and over. So just like really quick example of that, we could say, something that looks like this. Imagine if I drew those all nicely, that would be periodic because it repeats itself horizontally. If we had something like this, say if we had the zigzag, but it's moving down like this is not periodic because it has to go perfectly horizontal. All these peaks here have to be exactly the same. All these valleys all have to be the exact same y value. Okay, so that's periodic. Easiest way I think to describe this is to kind of just go into an example and show some stuff here. So this is an example from page 218. A Ferris wheel rotates anti-clockwise, we know that as counterclockwise, at a constant speed. The wheel's radius is 10 meters. So this distance right here is 10 meters. And the bottom of the wheel is 2 meters above the ground. So this distance right here is 2 meters. And about above ground level. It takes 100 seconds for a full revolution. So for this to go all the way back around and get back to here, it takes 100 seconds. So 100-second revolution. Okay. Andrew is watching a green light on the perimeter of the wheel because apparently Andrew has nothing else better to do than watch green light on a Ferris wheel. So there he is. He's watching this green light on the Ferris wheel. Sketch a graph of the height of the light above the ground versus time. Okay, so here's like a little graph here that we can use. And what we want to do is we want to go through and label this. Okay, so now it's important here. Let's see, this here is going to be our y, our height above the ground. And then this is going to be our time. So as time moves on, so is that green light is going to be moving around up here. Okay, so kind of cut to the chase here. We've got the height in meters of the light. So 2, 4, 6, 8, 10, 12, so forth and so on. And then this is time in seconds. Okay, so when time is at 0, so let's see, if this is 2 minutes, 2 meters, and this here is 10 meters, guess what? This right here is also 10 meters. So our starting height right here is at 12 meters. That's where that thing's going to start, right? Okay. And then we're going to go every 25 seconds, okay, because it takes 100 seconds per revolution. So if we go 25 seconds, that thing's going to go up here. And 25 seconds divided by 25 gives us 4. So it's 1/4 of the way around, right? Probably a better way actually would have been to be 100 divided by 4. And that gives us every 25 seconds is going to give us a quarter rotation, right? So after 25 seconds, we are up here, okay? So at 25 seconds, now we got to figure out how tall that is. This is going to be another 10 meters, right? So 2 meters plus 10 plus 10, that's up here at 22. So at 25 seconds, we've got another point here, okay? Now at 50 seconds, that's another quarter turn. Now he's going to be back over here, which is back. The light is going to be, not him, but it's going to be back over here, back at the starting point here again at 12. And then after 100 seconds, not after 100, but another 25 seconds. Now at 75 seconds, now we're down here at the bottom, which is at 2. Okay? And then back to 100. And that another 25 seconds is going to get us back to 100. And now we're right back to where we started from yet again. Okay? And then if we go through another rotation, guess what? 25 seconds, we're up here at the top. So now we're up here, and hopefully you're starting to notice, like, hey, look, this thing's going to probably repeat since it's on on a circle here, right? And then it comes back over here, back down at 0 after 150 seconds. And then at 175, that's 25 more seconds, we're down at the bottom, which is 2. And then back up to the starting point, which was at 12 meters. Okay? So, now, it's important to note that as this thing is moving, it's not going straight up and straight down, making a zigzag, but instead it's going to make a little bit more of a curve, right? So if you'll look at the height here, it's going up pretty fast right off the bat. So this is going to, instead of going straight towards this line here, it's going to go up faster. And then as we get closer and closer to the top, notice that our elevation gain, the up and down here, is pretty slight. So here, instead of being a zigzag, it's going to start off by going up fast, then it's going to kind of flatten out and come back down through here and do the same thing. It's going to kind of flatten out and come back up. It's going to make a nice little curve here instead of a zigzag. Okay, and this is actually a sine curve here. Okay. I got one other kind of quick little thing to take a look at here, and then all this stuff here. But let's take a quick little comedy break.
I went over to my dude Jeff's house to go visit him and his boys. I walk in the house, Finding Nemo's on TV. That's what's supposed to be on TV. You got little kids. I'm not worried about that. I'm actually a big kid myself. I actually kind of get into Finding Nemo. This is my favorite belt buckle. I'm a big kid myself, so I didn't have a problem with that. I sit down, I actually kind of get into the movie. Here's where I got upset, okay? We get to the point where we pretty much find Nemo before I realize I haven't seen a kid yet. I'm like, Jeff, where are the boys? He say, oh, they not here, they over their grandma's house. Okay. Then why are we watching Finding Nemo in the dark together with that candle over there? I don't like it. It's uncomfortable, and you should have told me.
Okay. So, we've just sketched our graph here, and again, sorry for the squiggles. It's not super easy to draw on this tablet. But here's what I want to do. I want to take a look at a little demonstration here that actually kind of shows this problem moving. Okay, so this is actually right in your textbook, and this is a little simulation, Ferris wheel simulation, and it's going to actually, here's our little green light, and it's actually going to rotate at our constant speed. It doesn't look like it's constant because, again, the videos on my computer is a little laggy here. But anyway, so this is our green light that we're watching. Okay, or that, was it Jeff? I can't remember who was watching this. Anyway, so there's our green light. Okay, rotating around. Now, we're going to kind of take some different perspectives on this. So here's our circle. Okay, so notice how the light moves in a circle. I think we saw that on here. But now here's where it gets a little interesting. So now we got it. We're viewing the Ferris wheel from, like if we're standing over here, we're looking straight at it this way here. And now look, notice how this thing is going up and down. This is really kind of our Y value on our graph here. If we can kind of move this over a little bit so we can kind of see at least the first part of it, right? So look, this is as this thing's going up and down, that's our Y value. And then if we look at another one, now it's actually going to graph it versus time. So remember, this is time. So look, here's our graph. And we're a quarter way through, we're at the top. Now we're at halfway through right there. We're back down at the middle. And when we get down to the bottom, we're down here. And then we're going to get back to where we started from. And we're back up here at this center line here. Okay, and then it's just going to kind of keep repeating. Okay, now another way to look at this is looking at it, say, from the top down. So we're like in this hot air balloon flew up over the top. We're looking down. So now we're going to look at it as it's moving left and right. Okay, so this is a little bit different. This is a little strange look at it. But here we started here. And now we're going, this is time, and this is our horizontal displacement, they're calling it. And so it's going to end up making another one of these little curve things. Okay? So it's just kind of an interesting way to just kind of take a look at it as it actually moves. I thought that was kind of interesting. And this, again, is in your textbook on page 218 if you want to see that. Okay. Last thing we want to look at is, I'm going to show you what all these things are here. Okay, so really what we do, here's our middle line, and this middle line here is where this is this line right in here. That's that middle line right there. And then here's going to be the top line, our maximum. And then here's going to be the bottom line, which is our minimum, right? So this here is the maximum. This is the minimum. And then this here is called the principal axis. Okay, this is the middle. It's the middle axis here. Okay, so we got principal axis, minimum, maximum. The amplitude is how far up it goes from the middle or how far down it goes from the middle. It's the exact same piece here. So like, let's say from right here to right there, this distance here is 10. So that means on this one here, our amplitude is 10. So it goes up 10 from the middle, and it also goes down 10 from the middle. Okay, that's our amplitude. So principal axis in this case is 12. Minimum was 2. Maximum is 22. And then the period. The period is how long it takes something to repeat. And we knew already from what it told us in here, but the period is 100 seconds. Okay, and we're in the next few lessons, we're going to take a look at what we can do with all that information to actually write an equation for this here. Okay, so we can find these values and graph them. So we graph those, and we are now able to find those values once we practice this a little bit more, and that's coming up here in a little bit. Let's see, I want to write the other thing. So this is the amplitude, and this is also the amplitude. These are both going to be the same. And then the period is just how long it takes for this to repeat. So from here over to here, right here, this here is the amplitude. Okay? If you have any further questions on any of this, please feel free to ask. Thanks.